Now we're ready to start building out the data models for our player and our monster when they enter combat. In order to do this, we're going to create a new actor class inside of our battle system scripts folder. Be sure to name this C# script actor. And let's open it up in MonoDevelop. We're going to use something called a scriptable object. The best way to think of scriptable objects is like prefabs, except they don't have any visual elements. So where normally you would drag a game object from the hierarchy into the project folder and still be able to edit it, a scriptable object allows us to serialize a class, store it inside of our project folder, and then reuse it in several different places in our code. Because this will be a scriptable object, we're going to remove monoBehavior and instead replace it with scriptable object. We can also remove the start and update methods as well. We're going to create a generic actor that will be able to represent the values that our player and our monsters will have in the game. We'll start by creating a few public fields. The first will be a new public field called string name. Now we're going to want to automatically expose this to the inspector. And because a scriptable object has a name, but it isn't exposed directly, we're going to go back and right before we define it as a string, let's add the new keyword to override the scriptable object's own name property. Next, we're going to create another public property that's typed to an int called health. And let's create another int for our maximum health. Whenever we're dealing with health on an actor, it's important to have the current health value and the potential maximum health that that actor can have. This way, if we ever want to restore the health or we want to heal the character, we can make sure that the health always stays at the value we're expecting. Now, let's add a new public int called gold, which will represent the amount of money that our actor is carrying. And finally, let's create a new public vector 2 called attack range. And here, we're going to set this to a vector2.1 property. This way, our vector 2 will have a 1 in the x and a 1 in the y. We'll use the attack range to calculate the attack power of our actor. Now let's add some helper methods to make it easier to work with our actor. We'll create a public property that returns a Boolean, and we'll call this alive. Here we'll simply create a getter, and inside of this getter, we'll return whether health is greater than 0. Next, let's add a helper method to decrease the health. We'll use this when the actor is attacked. This method will return void, and we'll call it decrease health. We'll supply an int called value for how much health to decrease by, and inside, we'll set the health value equal to mathf.max health minus value, or 0. This way, our health never goes below 0. Next, we'll create a method to reset our health. We'll make this public with a return type of void called reset health. Here, we'll simply set the health equal to the maximum health. And finally, let's create a new public method with a return type of void called increase gold. We'll supply an int called value. Here, we'll simply add value to our gold field. Now that we have our actor in place, we're going to need to create an editor in order to work with our actor. Let's go back into Unity, and in our Battle System folder, let's make a new folder called Editor. Inside of the Editor folder, we're going to create a new C# class called Actor Editor. Let's open this up in MonoDevelop, and we're going to need to bring in the Unity Editor namespace. We'll have this extend the base editor class, and we'll also delete the start and update methods. Now, in order for us to work with our actor, we're going to need a way to create one. To do this, let's set up a new menu item, and in the menu item, we'll set this menu inside of the assets/create/actor path. Next, we're going to need a static method in order to create the actor. So let's create a public static method with a return type of void called createActor. And inside of this, let's do debug.log and we'll simply output create actor. The last thing we need to do is associate our editor with the actor, and in order to do this, we're going to tell it that it's a custom editor, and we'll use a type of and pass in the actor class. Now let's save this and go back into Unity. Inside of our Battle System folder, let's create another folder, and we're going to call this Actors. And let's double-click into the Actors folder and right-click, and now from the Create menu, if you look all the way at the bottom, you'll see we have our actor. If we click on it, in the console, it'll output Create Actor. And now all that's missing is the code to instantiate our scriptable object.